name is Shashank and welcome to my channel Code with Shashank. In my last lecture, we have discussed about linear regression, cost minimization function, and how we can minimize the cost in order to get the best fit line using differentiation and matrix multiplication methods. If you are not able to recall it, you can go back and watch that video. Link will be provided in the description. In today's lecture, we will be discussing about gradient descent. It is a very important concept that you will be using in many of the machine learning algorithms in order to minimize the function to get the optimal solution. Gradient descent is an iterative optimization algorithm which is used to find the minimum of a function. Now, let us just try to understand how this algorithm works. Imagine a scenario. You guys will be sitting at the top of the mountain and you want to come back to the bottom. Okay, this bottom is your goal and it is also known to be as point of convergence. Okay, so you have to come down to this point. How will you start doing that? When you are at the top, you will start walking fast, which means you will take long steps. Okay, but when you will be near to this global minimum point, or we can say that the point of convergence, you will start taking smaller steps. Exactly the same is what gradient descent is doing. In order to reach to the bottom, when we start walking, gradient descent, we will take large steps and where the slope is steep. Okay, and when we are near to the goal or point of convergence, we will take a small step when the slope is less. We will decide a position based on the current location, and once we hit down the bottom, we will stop moving. This is the basic idea behind the gradient descent. Okay, what there are two factors that we need to understand. Okay, what if we start moving too fast and what if we start moving too slow? If we start moving too slow, it means like it will take a lot of time to reach to the bottom, to reach to the point of convergence. But if in case we start moving too fast, it could be possible we may skip this local or global minimum. We may randomly taking steps and moving upward and downwards, and after lot of interpolation we may come to this point. Okay, this steps is basically known to be as learning rate or alpha. Okay, so if you are able to see my screen, this is basically the formula for gradient descent, and we will repeat this process till convergence. Okay, in this formula, alpha will be the step size, or we can say that the learning rate. Larger the value of alpha, larger the steps. Smaller the value of alpha, smaller the steps. Similarly, this particular portion, partial derivative of j theta theta j, it's like 1, and this particular portion is known to be as slope. Positive slope means that theta will decrease, and the negative slope means that theta will increase. Okay, in gradient descent, we will calculate this value for each theta. Like here, since we are talking about simple linear regression, we will talk in terms of that. We will calculate this theta naught and theta 1. Okay, and we will update this simultaneously. We will not do that like we will calculate this value and assign this value to theta naught. This will affect this calculation for theta 1. Okay, so what we will do, we will calculate this value, assign it to a temporary variable. We will calculate this value, assign it to a temporary variable, and simultaneously we will update these values. Okay, let us understand the same equation in terms of y equals to mx plus c. We will be calculating the gradient descent for m and with respect to c. Okay, so we will be calculating the dj derivative of j c comma m with respect to c, and we will assign it to temporary c variable. In a similar way, we will be creating the calculating partial derivative again and assigning it to and this value assigning it to temporary m, and simultaneously we will be updating the c and m. Okay, we will repeat this process until the point of convergence is achieved. Okay, now one point is very important to understand: how to decide the learning rate. Okay, so this is something we need to understand. If we start taking the learning rate too large, it could be the chance that we may skip the like global minima or point of convergence or local minima. So instead of that, we will take the like small steps, and we will plot a graph between loss function, cost function, and basically the alpha, or the type number of iterations, you can say that. Okay, so we can get an understanding if the graph is like it will be continuously decreasing, it means our the learning rate is fine, and we can like tune it after increasing a small number. Let's suppose if you have selected the learning rate as 0.001 or 0.01, you can increase it to 0.02 and see if still it is fine, you can increase a little more, but you should not take the learning rate too high because it may skip the global minima. We need to understand the type of gradient descent algorithms available. Basically, there are two kinds of gradient descent algorithms. One is batch gradient descent, and another one is stochastic gradient descent. In a batch gradient descent, this will update the model only after all the training examples will be evaluated at each step. So like if you are like calculating here, you have provided a alpha value. If you are at this point, okay, it will calculate the gradient, it will update the model when it will calculate on each training examples, okay, at each step. Okay, so batch gradient descent is basically very slow over the large data set, and computationally it will be expensive. So it is not suggested for huge sample training sets, but it will definitely give you the optimal solution. However, it will take a lot of time to converge, and there could be a chance that it can trap into the local minima. We will discuss about local minima trap in subsequent lectures. Since batch gradient descent is considering all the training examples, hence the convergence will be slow. Let us discuss about stochastic gradient descent. Stochastic gradient descent, basically it will solve the main problem in batch gradient descent, and it will pick a random instance of training set instead of whole training set. Computation of the gradient descent using it will be faster in stochastic gradient descent, less time consuming. It can work over large training samples. It will give a good solution but not optimal. Let us understand the term stochastic given. Stochastic in nature means the pattern that may be analyzed statistically but may not be predicted properly. Okay, this is a very important line. In batch gradient descent, it will give a optimal solution if we will be giving a sufficient time to converge. But whereas in stochastic gradient descent, it will give you a good solution, but it may not be optimal. Okay, it may give you a pattern that may be analyzed statistically, but maybe it not predicting precisely. There's a good thing about is that gradient descent can escape the local minima easily, and it will reach the convergence faster. What is local minima basically? Local minima you can consider is a point where you can find there's a slope. Okay, this point, okay, this will be considered as a local minima. So this is all about gradient descent algorithm, and further we will look into the practical implementation of gradient descent algorithm and simple linear regression using differentiation method, using matrix multiplication method, and using the gradient descent method. Also we will look into the OLS function that is provided by machine learning algorithms, and we will also look into this linear regression model, which is provided by scikit-learn. OLS model is provided by the stats model in subsequent lectures. Till now, we will take a break. Thank you.